Hi, we're going to learn about absolute value today. An absolute value is like a function that makes anything inside it into a positive number. So if we were to solve for x absolute value, then the answer will be always positive. So even if x is less than 0 or is greater than or equal to 0, it's going to come out as a positive number. So let me write that x absolute value should be greater than 0, given that x is not 0. Let's solve an example, -3 in absolute value. Since -3 is a negative number, absolute value around it will make it into a positive number. So -3 into a positive number would be 3. So the answer to this question would be 3. To solve another example, 4 in absolute value. But since 4 is a positive number already, the absolute value will not have any change. So the answer to 4 absolute value will come out as 4. To explain the concept of absolute value easier, you can just think of a number line. So let's say the number we're trying to figure out is -5. So let's draw -5. So if you were to find the -5 inside an absolute value, then what you have to do is draw -5 a number line and find the distance between the -5 and 0. So that's going to be 5. And then what you have to do is move that distance from 0 to the right. So in this case, since the distance between -5 and 0 is 5, you have to move 5 from 0 to the right. So that's going to be 1, 2, 3, 4, 5, 5. In conclusion, -5 absolute value would be 5. What happens if there are things to solve within an absolute value? So let's say we have absolute value 5 minus 9. What you can do is just solve whatever is inside the absolute value. So that's going to be, in this case, since 5 minus 9 is -4, this whole expression is going to become absolute value -4. Like what we just learned right before, since absolute value makes anything inside it into a positive one, -4 will become a +4. So that's the answer. And to do one other example, it's going to be 0 absolute value. And this will be always 0 because, like what I mentioned before, if we draw a number line, 0 is right in the middle. So the distance between 0 and 0 would be 0. So the answer to 0 absolute value will be 0. Next, we're going to learn about how to graph absolute value. So let's draw an xy coordinate. This is going to be x-axis and this is going to be y-axis. Then y equals absolute value x will be drawn like this. To explain this graph looks symmetrical based on its reflection to the left of y-axis and to the right of the y-axis. And this can be explained by what we just learned. So when x is greater than 0, which is to the right of the y-axis, the x will always come out as positive. So y equals x on the right side. And similarly to the left of y-axis, x is less than 0, but when it goes through the absolute value, the x will always come out as positive. So the right side value will always equal the left side value despite the sign difference. And also because the absolute value makes every x value into a positive one, both right and the left side of the graph is above the y equals 0 line. But at x equals 0, y equals also 0 because 0 in absolute value will always be 0, like I mentioned before. So the center point in this graph will be 0, 0. Now we're going to do a little bit harder graphing, and that's going to have some more terms in the absolute value, and that's going to be y equals x minus 2 in absolute value. Remember, the y equals x absolute value graph was just symmetrical based on y-axis, but now since we are doing y equals x minus 2 in absolute value, it's going to be a little bit different. So what you have to do first before you graph a little bit harder equations like this is to find the point of symmetry. And just to explain, this graph will have a point of symmetry just because it's an absolute value graph, and every absolute value graph will have a point of symmetry in Algebra 1. To find the point of symmetry, you have to put the equation as equal to 0. So if you do that, x minus 2 in absolute value equals 0. And in this case, it's going to become 2. So when x equals 2, the y should equal 0. So in y equals absolute value x minus 2 graph, 2, 0 should be your point of symmetry. So let's draw this. 2 and then 0, 2, 0 is the point of symmetry. And let's draw 2 more points to the right of this point and to the left of this point, so we can see the trend in the graph and draw the whole graph. So if we were to draw the right of the graph, we can plug in x equals 3, so that's going to be 1 in this case, and then if you plug in x equals 4, then that's going to be 2. So 3, 1 and 4, 2 can be drawn. And then let's draw points to the left of the symmetry point. So that's going to be x equals 1. So if we plug in x equals 1 into the equation, we're going to have 1 because negative 1 becomes 1 when negative 1 is in the absolute value. And if we were to plug in another point, 0, if we plug in x equals 0 into the equation, we're going to get 2 because negative 2 in the absolute value becomes 2 when it comes out. So let's draw those points. It's going to be 1, 1 and 0, 2. So when you see this graph, you can see how it's symmetric to the point 2, 0. And now we will try to draw another example. Y equals absolute value 2x. This is a little bit different from other graphs we did, which is y equals absolute value x and y equals absolute value x minus 2, because the coefficient in front of x in this case is not 1 like before. And to draw this, we have to find the point of symmetry like we did before. So you have to set up in a way that the equation is equal to 0. So when 2x is equal to 0, x should be 0, so point 0, 0 should be drawn. Then let's draw 2 points to the right of the symmetry point and 2 points to the left of the symmetry point. So if you plug in 1, it's going to be 1 times 2, 2. So the point would be 1, 2. And if we plug in 2 into x, we're going to have 4. So it's going to be 2, 4. And if you were to do 2 other points to the left of the symmetry point, we can plug in negative 1. And if we do that, we're going to have negative 1 times 2, all in absolute value, which would be 2, because negative 2, when it becomes positive, it's going to become 2. And if we plug in negative 2 into x, then we're going to have 4, because negative 2 times 2 is negative 4, and everything in absolute value will make it positive, and the answer will be 4. So we're going to plug in the point negative 2, 4. So let's plug in the points 0, 0, 1, 2, 2, 4, negative 1, 2, and lastly, negative 2, 4. And if you connect the dots, it becomes a graph that looks like y equals absolute value x graph, but is not exactly same as it. And one difference to point out between y equals absolute value 2x graph and y equals absolute value x graph is that y equals absolute value x graph is a little bit wider than y equals absolute value 2x graph. This can be explained because y equals absolute value 2x graph should have higher y points than y equals absolute value x graph, because when the same x is plugged in, y equals absolute value 2x graph will have higher y values, so the y equals absolute value 2x graph should be a little bit more narrow than y equals absolute value x graph. One similarity between these graphs is that both go through the origin point, which is 0, 0. Today we learned about the concept of absolute value, how to solve absolute value equations, and how to draw absolute value. Thank you for watching.